let's begin by looking at how a simple circuit allows a light bulb to light. A circuit is a route through which electrical current can flow. In our example, electrons flow from the negative side of a D-cell battery to a conducting material on the base of the bulb. From there, the electrons flow up a wire that is inside the bulb and across the filament, which is the part of the bulb that actually lights. When the electrons go through the filament, some of the electrical energy is changed to heat and light energy. The electrons continue down another small wire inside the bulb to another conductor on the base of the bulb. The electrons finally make their way to the positive side of the battery. There would not be a complete circuit if the electrons did not travel to the positive side of the battery, and the bulb would not light. When there is an unbroken path on which electrons flow, as in this example, it is called a complete circuit. The unbroken path that the electrons follow is called a closed circuit, because electricity will only flow on an unbroken path. The light bulb will not light unless there is a closed circuit. Now look closely at the light bulb, and you'll notice that there is an insulator between the conductor that leads up to the filament and the conductor that leads away from the filament. Remember that the atoms of conductors easily accept and pass on electrons. The atoms of insulators do not. As we discussed in the first section of the lesson, electrons will not easily pass through insulating material that surrounds a wire. If an insulator did not surround a wire carrying a current, it is possible for the electron flow to get directed to another conductor that comes into contact with the circuit. Electricity will follow the path of least resistance. If the electrons take a path short of the complete circuit, it is called a short circuit.
Good day, grade 9 science students. Today what we're learning about is electricity again, but we're learning about circuits. Specifically, we're learning about current electricity. So our learning goal today is the following. We are learning how to draw what we call circuit diagrams, okay? And we're actually going to construct electric circuits here. And we're going to create things called parallel circuits and series circuits. We're going to learn about something called voltage. We're going to learn about something called current. We're going to learn something about resistance. And what does that have to do with a circuit? So here we go. So what is a circuit exactly? A circuit is an unbroken loop of conductive material that allows electrons to flow through continuously without beginning or end. So circuit keeps going on indefinitely. So for example, electrons can flow in a path without beginning or end, continuing forever. Imagine a hula hoop filled with marbles, and those marbles could move around that hula hoop indefinitely. This is what a circuit is. There's no end to it. It goes on forever. So any electric circuit in your house, for example, there will be continuous flow indefinitely. And if you have a break in a wire, for example, if you're going to go into your house and snip one wire, that would completely shut off the circuit. There would be a break in the circuit. So continuous flow cannot occur anywhere in a broken circuit. So if you do not have a continuous wire, electrons can't flow and electricity will stop. It doesn't matter where the break occurs. You saw that previously we had 4 sides to our circuit and the break was happening on this side. If it happens on this side, the electricity can't flow at all. So it doesn't matter where the break occurs. That means that you have a broken circuit and electricity stops flowing. So one of the qualities that an electron has as it moves throughout a circuit is its voltage. And an easy way to remember what voltage means is the amount of energy each electron has. The formal name of it is known as electric potential difference. Okay, so that's the scientific terminology that we use. But it's really easy to just think about how much energy each electron has, and it's measured in volts. And we actually measure that using a voltmeter, and it measures the volts or the amount of energy that each electron has within that circuit. So as the electron uses up its volts, it loses the ability to turn on a light bulb, for example. So when we talk about electric potential difference, what does that mean? Well, electrons will not just simply move through the circuit. They have to have a certain amount of push behind them. And that push is the potential energy, the amount of energy that each electron has. And it's set up by the original power supply, or the battery, that is pushing the electrons through that circuit. So when work is done by the power supply to increase the electrical potential energy of each Coulomb of charge from a low value to a high value. So I'm going to talk to you what a Coulomb is. A Coulomb is really an amount of electrons. So as the charge flows through the load, its energy decreases. What that means is that as that energy, or so as that electron moves through the circuit, it goes through lights, it goes through things that sort of slow it down. And as it moves through those things, it loses some of its energy as it does that. So slowly the voltage will decrease throughout that circuit as it goes through lights and resistors and even the wire itself. It will slow it down and it slowly loses its power. So let's talk about what a Coulomb is. But a Coulomb is really just the amount of electrons. So we know that we can measure electrons, or the amount of electrons, in something known as a Coulomb. So this French physicist, he worked on electric charges and he made several important discoveries, and he named Coulomb, a metric unit of electric charge, is named after him. And 1 Coulomb equals 6.24 times 10 to the 18 electrons added to removed from a neutral object. So it's a lot of electrons. So when we talk about electrons moving through a circuit, there's a lot of electrons moving, and their voltage decreases as it moves through that circuit. And it goes through resistors and things that slow it down. We're going to define what resistors are a little bit more thoroughly. So as the electrons flow through that load or resistor, another word for resistor we're going to use is load, its energy decreases. And so that load or resistor can really take that energy and convert it into a different form of energy. For example, as an electron moves through a light, it takes that energy and it converts it into light energy, so you can see. Another way for us to think about this is thinking about water flowing past a water wheel. And if we look at this diagram below here, the wheel converts some of the energy of the water into motion. The water has more energy before the wheel than after the wheel. So as that water goes through a pump, for example, or a water wheel right here, you can see what I'm pointing at, hopefully, and it has lots of energy before it goes through the pump, but after it comes through the pump, it has lower energy or lower pressure. And similarly with a battery, you have high current flow going through, and then when it goes to the resistor or the load, in this case it's a fan, it leaves and it has low energy on the way out. So we measure potential difference using a voltmeter, and a voltmeter must be set up in a way known as parallel. Okay, so parallel means it's an alternate path through that series. So I can't break that circuit. I can't break that circuit up, but I can flow beside it, and we can measure how much energy those electrons have in volts, and we use a voltmeter. So we normally measure before and after a load. Now a load could be a light, it could be a resistor, it could be anything that's slowing down those electrons and is using that energy to turn it into a different form of energy. So we can also measure something in circuits known as current. And current is different. What current is, it's how many electrons pass by each second. And it's measured in amperes. Now we're going to learn that currents can kill you, voltage can't. And voltage is the amount of energy each electron has. Current is the amount of electrons passing by each second. So we use something known as an ammeter to measure the amount of amps going through the circuit. So think about it in terms of a waterfall. If you count the number of water molecules dropping off the edge every second, you can get a rate at which water is passing past a particular point. Now think of the water molecules as electrons in a wire running through a particular point in a specific amount of time. And you have the concept of current. It's basically the amount of electrons that are flowing through. So when we want to measure amps, which is the amount of electrons, or volts, which is the potential energy of each electron, we want to actually connect them in a certain way. So you connect the ammeter to measure the amps, and we connect it in something known as series, which I'll explain later. And a voltmeter, which I already said we connect in parallel, we'll also explain later, to the circuit. When you connect it to the circuit, you also have to remember that you have to connect it to the right wires. Now, normally you have colors for specifically in your car. Open up your hood and you'll look in your car and you'll see black wires and red wires. The black wires are the negative terminal, and that's where the electrons are leaving. And the red wire is the positive terminal. Now, the negative wire, the black wire, it has a lot of potential energy. It has a lot of volts coming out of there. And the red wire, the potential energy has already decreased. So it's very dangerous to touch that black wire. As opposed to the red wire, which is less dangerous. And you always want to make sure that when you hook these things up, an ammeter, or even you're trying to jump your car, that the black wires go to black wires and the red wires go to red wires. In other words, always connect the positive terminal of the meter to the positive terminal of the electric source, and the negative terminal to the negative terminal of the electric source. If black goes to red, positive goes to negative, you create a short circuit, and that's going to cause some issues for you that can be extremely dangerous.